Creare and NASA are working together to develop new technology to produce electric power in space. All the cool things we want to do in space, they all require electric power. And we can't simply bring conventional generators from Earth up into space to make that power, because those systems use air to burn fuel, and there's simply no air in space. So we're working with NASA to develop a power generator for space that's driven by heat from nuclear materials. And these systems are intended to be used in places where solar power is impractical. Our approach uses the same thermodynamic cycle as the jet engine uses, but we have to configure the engine to be a closed loop with a fixed amount of fluid flowing through it in a circular fashion. The system also requires a small turbo machine that spins at thousands of revolutions per second, which is hundreds of thousands of revolutions per minute and up to 1 million revolutions per minute in some cases. These high speeds make the system extremely compact, lightweight, and efficient, which is important to make launch feasible. We achieve these high speeds with non-contact bearings that support the rotor on a thin film of gas. These gas bearings give the engine essentially infinite life without maintenance or performance degradation, which is a key requirement for use in space. This technology is particularly appropriate in places that are far from the sun. Nearer to Earth, solar panels are quite effective, but as we get out further and further into outer planets and beyond our solar system, these types of power systems that can convert long-term nuclear fuel into electricity are what's needed to explore those far reaches of the universe. The power levels of interest range from hundreds of watts to hundreds of kilowatts. And we have, at Creare, we have very tiny turbo machine technology that's appropriate for the very small sizes. And we're currently in the process of scaling that up to larger sizes where greater demands are. And fortunately, it's very easy to scale up in size. It's much harder to scale down in size. We've been working on this type of technology for many decades, and we've really mastered the small end of the scale. And we're looking forward to going to bigger sizes for bigger spacecraft and bigger missions with greater science benefit. So I've really enjoyed working with NASA for almost 20 years now. I've got to do some really fun things. I've got to be on the space shuttle. I've got to put things in space. And it's very gratifying to see something you built go up and be used in space, and for learning things about the universe that teach us all new things. I think that's very exciting for anyone that's interested in going into this type of business. Everything is new, challenging, it's all cutting edge things, and you really force yourself to find the new limits of